Hello GATE aspirants, welcome to part 11 of GATE Electromagnetic Theory series. Question number 9. A medium epsilon r is greater than 1, mu r is equal to 1, sigma is greater than 0 is semi-transparent to an electromagnetic wave. Then here conduction current and displacement current comparison is there. So conduction current density Jc is equal to sigma into E, and that is, let us consider it is some sine function, so this will be sigma into E naught into sine omega t. Now displacement current density Gd is equal to epsilon into dou E by dou t. So that will be equal to derivative of this will be omega E naught into cos omega t. Now this is sigma and omega into E. Now for semi-transparent material, if we are considering semi-transparent material, in that case omega epsilon naught has to be much greater than conductivity sigma. So this is the case, that means this Jd will be much greater than Jc. So conduction current has to be much smaller than displacement current. So option B is correct. Next question. Which one of the following relations determine the manner in which electric field lines are refracted along the interface between two dielectric media having dielectric constant epsilon 1 and epsilon 2? So here comparison of angles is there. Now tan theta 1 upon tan theta 2, this will be equal to, this is parallel upon perpendicular component, so this will be E1 parallel upon E1 perpendicular, and this will be tan theta 2 will be equal to E2 parallel upon E2 perpendicular. Now parallel components are continuous, so we have E1 parallel is equal to E2 parallel. Along the boundary the tangential component is continuous, so this will be equal to E2 perpendicular upon E1 perpendicular. Now we know D2 perpendicular is equal to D1 perpendicular if there are no free charges. So this can be written as epsilon E1 perpendicular into epsilon 2 E2 perpendicular. So from here E2 by E1 it will be equal to epsilon 1 by epsilon 2. So this is epsilon 1 by epsilon 2. So that is epsilon 2 tan theta 1 is equal to epsilon 1 into tan theta 2. But this option is not there. So here tan theta 1 can be written as, we can take reciprocal on both sides. So this will be equal to 1 upon tan theta 2, it will be cot theta 2. So here we will have cot theta 2, and 1 upon tan theta 1 is cot theta 1. So here option D is correct. Next question, 18. Far from the Earth's magnetic field can be approximated as due to a bar magnet of magnetic pole strength 4 into 10 to the power 14 ampere meter. Assume this magnetic field is generated by a current carrying loop encircling the magnetic equator. The current required to do so is about 4 into 10 to the power n ampere, where n is an integer, the value of n is, and Earth's circumference is given, that means 2 pi r is equal to 4 into 10 raised to 7 meter, this is given. Now pole strength is given, from here magnetic moment will be Qm into L. So length will be the diameter only, so this will be Qm into 2r. But magnetic moment is also equal to current into area, and area will be pi r square. So from here I is equal to, r and r will cancel, 2 into Qm upon pi into r. So that is 4 Qm upon 2 pi r. So from here 4 into Qm is 4 into 10 raised to 14 upon 2 pi r is 4 into 10 raised to 7. So that is 4 into 10 raised to 7. So the power is 7. So n is equal to 7. And answer in the answer key is 7 to 7. Next question, 24. A conducting sphere of radius 1 meter is placed in air. The maximum number of electrons that can be put on the sphere to avoid electrical breakdown is about 7 into 10 raised to n, where n is the integer, the value of n is. Now E is equal to 1 upon 4 pi epsilon naught into Ne by r square, and this has to be less than this breakdown voltage, so 3 into 10 raised to 6. Now 1 upon 4 pi epsilon naught is 9 into 10 raised to 9 into we have n into 1.6 into 10 to the power minus 19 upon the radius is 1 meter, so this will be 1 square. This has to be less than 3 into 10 raised to 6. So 9 into 1.6 is 14.4 into 10 to the power minus 10 into n. This has to be less than 3 into 10 raised to 6. So from here n should be less than 3 into 10 raised to 6 upon 14.4 into 10 to the power minus 10. So from here n should be less than 2.08 into 10 raised to 15. Now this power is asked, so from here n is equal to 15, and answer given in the answer key is 14 to 15. Next question. A uniform magnetic field B bar is equal to B naught y cap exists in an inertial frame K. A perfect conducting sphere moves with a constant velocity V bar is equal to V naught x cap with respect to this inertial frame. The rest frame of the sphere is K dash. The electric and magnetic fields in K and K dash are related as the induced surface charge density on the sphere in the frame of K dash is. So we'll use this formula and we'll try to find out E dash and B dash. Now E dash perpendicular direction, it will be gamma of E perpendicular plus V cross B. But here E perpendicular is 0. So that means this will be 0. So this is equal to gamma into V cross B. So gamma into velocity is V naught x cap cross B is equal to B naught y cap. So that is gamma V naught B naught x cap dot y cap is z cap. Now B perpendicular, this will be equal to, let me use dash here, this is equal to gamma into B naught. So here let us write B there. So minus V upon C square cross E bar. So E is 0. So that means this will be gamma into B perpendicular. So that is gamma into B naught into y cap. Now induced surface charge density. So from there we can write D1 perpendicular minus D2 perpendicular, that will be equal to that surface charge density. And this can be written as, this will be epsilon naught E minus 0 is equal to surface charge density. And epsilon naught E is this. So this will be epsilon naught into gamma into V naught B naught z cap is equal to this. So it is along z cap direction. So maximum value, this maximum value, it will be along z cap direction. So here option A is correct. Along y direction it is gamma into, then we have to calculate also. But it is from here it is we are getting it is maximum along z cap direction. Next question. A charge q moving with uniform speed enters a cylindrical region in free space at t is equal to 0 and exits the region at t is equal to tau. Which one of the following options best describe the time dependence of the total electric flux through the entire surface of cylinder? Now flux is equal to q enclosed upon epsilon naught by Gauss law, and charge enclosed is q. So q by epsilon naught, this will be constant. So this will be inside it, and phi will be again q enclosed by epsilon naught, but it will be 0 for outside part. So inside it will be constant and outside it will be 0. So here option D is correct. Next question. A plane electromagnetic wave of wavelength lambda is incident on a circular loop of conducting wire. The loop radius is small as compared to lambda. The angle made by the Poynting vector with the normal to the plane of the loop to generate maximum induced electrical signal is. Now Poynting vector is 1 upon mu E bar cross V bar, and E is equal to minus d phi by dt. Now to maximize E, this phi should change rapidly. So this phi should change rapidly. That means this B bar has to be perpendicular to the plane of loop. So B bar is perpendicular to plane of loop. So let us consider that direction to be z cap. Now if it is along z cap direction, then S bar is perpendicular to B bar. That means S bar should be parallel to plane. S bar is parallel to plane of loop. S bar is equal to cross product of E bar and B bar. If B bar is perpendicular to plane of loop, then S bar is parallel to plane of loop. So this angle can be, theta can be plus minus 90 degree or plus minus 270 degree. And answer in the answer key is minus 270 or minus 90 or 90 or 120. Next question. A sinusoidal voltage of the form V is equal to V naught cos of omega t is applied across a parallel plate capacitor placed in vacuum. Ignoring the edge effects, the induced EMF within the region between the capacitor plates can be expressed as a power series in omega. The lowest non-vanishing exponent in omega is. Now we know E is equal to minus d phi by dt. So that is equal to minus a dB by dt, and line integral B dot dl is equal to this. We will use Maxwell's relation, mu naught I enclosed plus mu naught epsilon naught surface integral over dou E by dou t dot dA bar. I enclosed, current enclosed is not there because it is capacitor, so this will be 0. So from here we will get this B dot dl. So from here B into 2 pi r is equal to mu naught epsilon naught into, this is dou by dou t of E. From here we can calculate E. So E is equal to V by D. So this will be V naught cos omega t by D, because that separation between the two plates is fixed. So this will be dou by dou E of this. So this will be V naught. Derivative of cos is minus of sin omega t into omega upon d, and this is dA, integral over dA. So that will give us area. So that is pi r square. So from here we can see B is proportional to omega into sin omega t. All other things are constant. So it is proportional to this. Now if B is proportional to this, then means E will be proportional to derivative of B is E. So that means E is proportional to derivative of this. So that will be derivative with respect to time. So that will be sin derivative is cos omega t into omega square. So E is proportional to omega square cos omega t, that is omega square, and this cos omega t can be written as, we will use cosine series, cos theta is equal to 1 minus theta square by 2 factorial plus theta raised to 4 factorial minus theta raised to 6 factorial, and so on. This series we will use. So this is minus of omega square t raised to 4 by 2 plus, and so on. Now the lowest non-vanishing exponent in omega is, this first one is omega square. So here answer is 2, and answer in the answer key is 2 to 2. So these were all the questions from GATE 2020 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.